So another very interesting string instruction is basically the operation where you want to search for a particular occurrence of a certain hexadecimal value in an array. Okay. So let us say that, for example, I have an array like this. Okay. And this is my extra segment, right? And let us say that, of course, each of these could be a byte of information. Okay. And right. So it's a byte of information, and let's say that, in each byte I have some different color as usual to indicate. The last one could be magenta or something like that, and somewhere in between I have this red data sitting like this. Okay. Now what I want to do is, so let's assume that this red is some 0xFE. Okay. I want to see, starting from certain address, does this value 0xFE occur within a certain range of that memory. Okay. So what am I going to do? I am going to, as usual, assign my destination index to this. Okay. And I want to call this offset underscore destination, right? Offset underscore destination. So let's say move di comma offset underscore destination. Remember, the destination index register is always associated with the extra segment. Now I want to search for a certain value, right? Where am I going to store that value? I am going to, the x86 allows you to use only one register to actually store this specific value that you are looking for, and that is the AL register, because I am looking for a byte of information. So you do AL comma 0x, I put that in red to highlight that it's the same value, FE. Okay, it's the same value that I am putting there, right? And let's say that I want to look for this particular pattern in 8 bytes of 8 different bytes of information. Okay, so I am assuming that this distance, this count is actually 8, spans 8 memory locations, 1 byte each. So what do? Move ECX comma 8, because that's the max count. Now what am I going to do? I am going to use the very specific string instruction that will allow me to scan for this pattern. So the instruction is SCASB, SCAS byte. Okay, you are going to scan and look for the byte of information. Which byte of information? What is in AL register? You are going to search through starting from the location DI. Now, after you execute SCASB once, what will happen to the DI register? It will increment by 1. It will increment by 1 automatically. Okay. So after this, it will basically, so if you look at what this instruction does is, it will compare the contents of AL with the contents of DI. And of course, contents of DI means extra segment colon DI. Colon means you are taking extra segment value, multiplying it by 0x10 and then adding it to DI. That's what I mean by the full address. So you're going to compare and then you will increment DI depending on whether you are setting or resetting the direction flag. So di will then become di plus or minus 1 depending on direction flag equal to 0 or 1. Okay, so therefore, in this sequence, I have to do CLD so that I do auto increment of my SI and DI, right? This is auto increment. Okay, sorry, increment. Yeah. So you're going to move the DI, you're going to initialize it to the offset destination. Then you put the pattern that you want to search for in AL, the count of the array size in ECX, and then you do SCAS byte, right? It will compare, right? And of course, what should I do here? I do REPNE or REPNZ, it doesn't matter. So this SCAS byte is going to compare AL with this, with the contents of DI, and then it will increment DI by 1, okay, because CLD has been executed. The REPNE is going to execute this, then decrement CX by 1, right? Again it will decrement by 1. So what is going to happen here? You are starting with this blue value, CX value is 8. So it compares this whole thing. It compares DI, contents pointed to by DI with AL. It is not 0xFE, it's not the red value, it goes on. The second value no, third, fourth. So now what has happened? CX has decremented 4 times. 8 has become 7, 6, 5 and 4, right? Now you hit this point, right, of the red 0xFE and you have found it, right? And therefore, this REPNE SCAS byte will exit, will stop and come out of the loop, right? So either in the end of this REPNE, right? So how do you find out whether that pattern existed in that array or not? It's very simple. You basically have to go ahead and check the value of ECX. If ECX hits 0, right, it means the pattern was not found in any of these things, and that's why it has gone ahead and incremented the DI all the way to the maximum value that you set in ECX. Otherwise, it has found it somewhere in between, and therefore, based on that, you do know that whether the pattern exists in this particular array out here or not. Okay. So just like the SCAS, the moves byte, moves word, moves the word, you can also have moves word, SCAS word, SCAS D word, right? And this will basically do compare. So when you want to now compare, when you want to do compare a word with what is in the memory, with words that are in the memory, then you have to load that pattern in AX. Okay, so that is very important. So let me write these 3 separately. SCAS word is going to compare AX with contents of DI, and then DI will be DI plus 1, okay, plus or minus 1 depend on direction flag, right? Now D word, it will compare EAX with DI, and then DI will auto increment or plus or minus 1, direction flag equal to 0 or 1. So this is not, sorry, when you do SCAS word, it has to be plus or minus 2, SCAS D word, it has to be plus or minus 4. Okay, so this is how you use the SCAS, the scan string operation, in order to search for a particular pattern in an array sitting in the extra segment. A final string operation that we would like to discuss in this course for the x86 architecture is the CMPS operation. This is basically going to compare 2 different memory arrays in order to see if they are basically the same, and then it will obviously stop wherever they are different. Okay, that's the idea. So CMPS is very similar. If you look at it, there is no data movement, but instead of the movement, you are going to compare values in these memory locations, just like you did in the moves byte. Moves byte, you actually move data from SI to DI. Here you are just going to compare contents of SI and DI, and then keep doing this for using the REPNE operation, right? So here compare CMPS, right, is basically going to use going to perform the following operation, which is going to effectively compare contents of SI with contents of DI, right, and then SI will either SI plus or minus 1, again CMPS B. Okay, we are going to do compares byte or compares word or compares D word. So destination index DI plus or minus 1. So this is what the compares byte thing will do, right? And what are you going to do? You're basically going to use it. Just I can give you the example of the just like I did for moves byte. You start here. One is this is the data segment, this is the extra segment, right? And what I'll do is, so just like maybe what I'll do is I'll give the example this time with the D word rather than the word or the byte. So you can also do CMPS word, which effectively is going to compare contents of SI with DI. Okay, remember, very important, here it is actually byte pointer. Okay, implicitly I am not writing that here. Out here it is word pointer, right? And then SI will auto increment plus or minus 2, DI will become DI plus or minus 2, right? Plus or minus is of course determined by the direction flag. CMPSD is compare contents of SI with DI, right, and this one is D word pointer. For both SI and DI, SI is SI plus or minus 4, DI minus 4. Okay. So as usual, what you can do now is, let's assume that I have like 4 memory locations. Okay, this one is going to be some value in blue, right? This one is in red, this one is in magenta, right, and this one is in orange. Okay, so my source index is going to point here, SI. Now this is my data segment, this is my extra segment. Okay, so let's assume now in the extra segment my destination index is going to point to a certain array, right, and let's assume that that first location is also blue. Whatever the blue value was in the data segment, it's exactly the same thing. Then we'll assume that the second D word, 4 bytes, is also the same as what was in the data segment, right? So now what you do, you basically say the third location, let's assume that this is different. This is my green color, which is a different value from what the third location D word was in the data segment, okay. And it does not matter, maybe the fourth value can still be the same as what it was. Right. So, what I want to now do is, I want to compare these two arrays, right. Now, of course, when you compare these two arrays, you know that this whole comparison, of course, these two arrays are not the same, because the first two locations, of course, for this you also have to define that the array size is 4, because we are talking of 4 different locations in memory, right. So, we are talking of this being 4 D words. Okay, it is spanning 4 D words in both cases. Only then I can talk of a comparison of 2 arrays. So, assuming that you are doing that, then you know that the first 2 values are the same, blue and red. The magenta has now changed to green, okay, and therefore the array is different for the first time at that particular location, okay. So, let us say I want to find out where it is different, okay. Where it is different. So, what will you do? You will basically say CLD, so that you clear the direction flag, so that you are auto incrementing the source index destination index register, right. Then I will say move SI comma source offset, then move destination index comma destination offset. Right. So, I am doing that, and then what am I going to do? I am going to load the count, move ECX comma how many? 4, my array size is 4 in this case, right. So, now what am I going to do? I am going to do CMPSD, CMPSD word. So, what will happen if I executed just this instruction once? So, let us copy this and then look at the sorry, yeah. So, if I executed just CMPS, if I executed all these instructions, right, what will happen? My SI will get incremented by 4, DI will get incremented by 4, right, and the compare operation would basically say that, yeah, these two locations are basically the same, right. So, now what you do is, I go ahead and add my prefix REP NE, so that I perform this whole comparison in order to repeat this whole comparison one after the other. So, what will happen? It will compare blue with blue, it is the same, then it increments SI and DI by 4, then it compares red with red, yes, both are same, then it will, and in the meanwhile it has decremented ECX by 2, because it has done this loop twice. So, ECX, which was 4, has become 3 and then 2, right. Now, again you compare SI and DI, because now SI and DI are pointing here, right. It's pointing here, right. And then what are you going to do? You will compare the magenta with green, they are different, and therefore this loop will basically stop and then come out, right. So, therefore, you know that from the value of SI and DI, you know the exact location or the first occurrence of the memory location where these two arrays are actually different, right? So I leave it as an exercise to you to go and read up a little more on this instruction and understand how to use it more efficiently for some array comparison operations.